Let's begin notes for section 8.3. So we're looking at trigonometry functions of any angle. And we're going to start by looking at the three special right triangles. Now you were introduced to these earlier in your high school math education. And so they should look a little bit familiar. So this first one, if you recognize, it's a 30, 60, 90 triangle. The second one is a 45-45 triangle. The third one is also a 30, 60, 90 triangle. But on this one, we're going to focus more on this 60-degree angle. And you'll see why in just a second. But what we're going to look at is first, what are the lengths of the three sides if the hypotenuse is 1? And notice the hypotenuse is 1 on all three of these angles. So that's going to help us remember that. So on a 30, 60, 90 triangle, the short side is always half the distance of the hypotenuse. Hopefully you remember that. So if the hypotenuse is 1, then the short side is 1/2 or 0.5. I'm going to leave it as a fraction. That's going to make it a little easier. Then the long side is the short side times the square root of 3. So that would just be the square root of 3 over 2. Okay, be sure you write these in your notes. We're going to use this information a little bit later. In a 45-45 triangle, if the hypotenuse is 1, the short side, or the legs, where the hypotenuse divided by the square root of 2, so that would be, I'm just going to show my work over here, 1 divided by the square root of 2, but remember we have to rationalize the denominator, so we're going to get rid of that square root in the denominator. So our leg length ends up to be the square root of 2 over 2. And because it's a 45-45, 90 triangle, the leg lengths are the same, so square root of 2 over 2. In the 60-30 triangle, we've already figured that out, so I'm going to go ahead and put those values in. The short side is 1/2, and the long leg is square root of 3 over 2. Now we're going to take those three angles and we're going to put them on a coordinate plane. So we'll have the coordinates, the 4 coordinates with the circle drawn in. And what we're doing is we're actually building the unit circle. The unit circle, I don't know if you've heard of it before, but it is famous and we're going to use it a lot. So this is really cool. This is how the unit circle is made. And I really think this will help you understand how to use the unit circle if you understand how it is made. So we're going to think of those 3 triangles that we just found all the sides for in the previous slide. And we're going to put it in the positive, x-positive coordinate. So first, if you think of putting the 30, 60, 90 triangle on here, notice the hypotenuse is 1 of all of them, and then that's what's going to make this circle. So this is going to make a circle whose radius is 1. So we're going to put all 3 triangles on the x-positive axis. And we're going to take those points, and those points are going to start the creation of this unit circle. So now we're just going to kind of think back to what those values were. So in a 30, 60, 90 triangle, remember this side here was the square root of 3 over 2. And this side was 1/2. So if you put it down here on the unit circle, that would mean that we are going over square root of 3 over 2 and up 1/2. So that would make this point right here, or I'm going to come back to this one. This point right here would be 1/2, square root of 3 over 2. That would be the x coordinate, and then 1/2 would be the y coordinate. And do the same thing for B. For B, the coordinate would be the square root of 2 over 2, because that's how far over you're going in the x-positive direction. And then you're going up square root of 2 over 2 also, because those two distances are the same. Point C, would then be over 1/2. So it's 1/2. And then the square root of 3 over 2. Sorry, handwriting is very bad, but that should help you with this. What is the radius of the circle? Well, I already said just a minute ago, these hypotenuses or hypotenusae, they're all the same, and that's what's creating the circle going around. They are all 1. So the radius of the circle is 1. Okay, now we're going to think about those coordinates. And for our 30 angle, our 45 angle, and our 60 angle. So go ahead and fill in this table with what those coordinates were. Well, on the 30-degree angle, it was the square root of 2, comma, 1/2. On the 45, it was the square root of 2 over 2 for both legs. So that was over square roots of 2, up square roots of 2. And for the 60 was just the opposite of the 30, so it was 1/2 and then square root of 3 over 2. Okay, now we're going to look at something, and it might not make really good sense right now, but it's going to make sense in just a minute. So we're just going to find the value of the sine of 30. So grab your calculator and just see what the value of the sine of 30 degrees is. Now, if you need to pause, you can, but the value of the sine of 30 is 1/2. The value of the cosine of 30 degrees, and if you look at it, it's in a calculator, it's 0.87, but guess what? 0.87 is the same value as the square root of 3 over 2. Now, another way you could look at it is if you did the sine of 30, you could look back at your triangle and do opposite over hypotenuse. So, and you would get these same values. So, yeah. So anyway, the next one, 45, the sine of square root of 2 over 2 is 0.7, which is the same as the square root of 2 over 2. And also the cosine of 45 is also 0.7, which is the square root of 2 over 2. Okay, and then same thing for 60 degrees. The sine of 60 degrees is 0.87, which is the square root of 3 over 2. And the cosine is 0.5, whoops, or 1/2. Okay, now look at the sine and the cosine and compare it to the x and the y value of the coordinates. So in your notes, I want you to write down what is the relationship that you notice between the coordinates on the unit circle and the value of the sine and the cosine. Okay, so think about that for a minute. If you need to pause a video while you think about it and look at the comparisons there, do. But here's what you should notice. The sine of the angle is the same thing as the y value. The cosine of the angle is the same thing as the x value. It's going to become very valuable in just a minute. For this last part, we're going to look at the whole positive coordinate right here. So look at the point shown below, which corresponds to 90 degrees. We're looking at this point right here, 90 degrees. What are the coordinates of that point? Now again, throughout this whole thing, if you want to pause the video and think about it for a second, then you probably should do that because it will make more sense to you if you can understand that. But the coordinates are 0, 1. Now, if you took the value of the sine of 90 from the previous slide, what do you kind of expect it to be? Remember, the sine of 90 was also the y value. But do it. Just plug it in your calculator and put in the sine of 90. You do get a value of 1. What's the value of the cosine of 90? Again, we got the x coordinate, but try it with your calculator. The cosine of 90 is 0. What would the coordinates of the point, what would be the coordinates of the point that corresponds to 0? So if we're looking at this point right here, that would be 1, 0. So what is the sign of 0? Well, the y value is 0, but if you put in your calculator sine of 0, you do get 0. What's the cosine of 0? And it's 1. For the next part of the notes, you should have downloaded and printed what I called the blank unit circle. This is kind of part B of your notes. So the first part was just a 1/2 size that would have fit nicely in your notebook. Then this next one, it's a full-size unit circle on a full-size sheet of paper. But what I want you to do is somehow figure out how to just put this part of it into your notes, because we are going to build the unit circle, and this will be a really important reference for you in your notes. On the bottom of the sheet, there are 3 triangles. And what you can do is just cut those triangles off, and then what you can do is place the lengths of each of the sides inside the triangle, so that you cut the triangles out so the lengths are still in there. And then you can use them to help build this unit circle here. So you'll kind of see what I mean as I go through that. So if you need to pause this, paste in this unit circle, grab your 3 triangles, and let's start building it. So now I'm just going to show you how to use these triangles, and then you can use them on your unit circle. I won't be dragging them in every time. But say you have the 30, and I'm trying to show the best here that I can. If you line it up so the bottom line is on the x positive and the terminal would be right there, this point would be on the unit circle because the radius is 1. So then you would notice that the values here would be that the x is going over square roots of 3 over 2. So you're going to fill this in, square roots of 3 over 2. And the y value of that point right there is 1/2. You could also do it for the 45-45 triangle. Drag it over here, and then you can see that the x value of that point is square root of 2 over 2. So you fill that in. And the y value is also square root of 2 over 2. And also for the 60-degree triangle, if you bring it in, then you can see that the x value of that point is 1/2. We would write a 1/2 in here. And the y value is the square root of 3 over 2. Then we can also look at it and recall what is the value of the point at the 0 term. So if you remember, that was 1, 0. And for this value right here at the 90-degree, it was 0, 1. Now, what I want you to do is go ahead and fill out all the rest of these, because you've got all the values that you need right here. Now you just have to think, okay, so instead of 1, 0, this one is going to be -1, 0. So -1, 0. Instead of a positive 3/2 over 1/2, it's going to be negative square roots of 3/2 positive 1/2. So write these in. Now I'm writing with the mouse, so my handwriting is really sloppy. But as you fill these in, try to make these as neat as possible, because this is going to be your reference sheet that you're going to use a lot. So try to make these very neat so you can read them good. And go ahead and complete the rest of the table. Pause the video for a minute if you need to, and then turn it back on when you have it done and check to make sure that you've got all of the points right. And here's the completed unit circle. Now we're going to be using this a lot. I'm also going to show you one that is printed off a little easier to see.